right, thanks Josh. Thanks for inviting me. Thanks for all coming. I'm sure many, if not all of you, are familiar with two-spotted spider mite, at least a little bit about it. I just want to go over some of the basics so that we're all on the same page to start. Two-spotted spider mite starts its life out as an egg, usually on the underside of a leaf. That's where you got to look to find them. Those eggs hatch. The first stage is called a larva. That larva is quite small. This is the larva up here. This is the egg, so about the size of the egg. Develops through 2 nymphal stages, and then it becomes an adult, male or female. Just a few pictures. There's an adult, there's some of the eggs, and on this slide we have there's some adults, there's some nymphs, there's probably some eggs and larvae as well that are really small. So I just want to move on. Josh asked me to just go over a few things about two-spotted spider mite and temperature. So how long do these things live? How fast do they reproduce? And how quickly do they develop from egg to adult? So I don't have any of my own data on this. It's my first strawberry season here, but went to the literature and found a couple papers. So I just want to go over some numbers so you have some general ideas about how quickly they develop. So here's a paper from 2001, and this is what they found at constant temperature in the laboratory. So at 15 Celsius, 59 Fahrenheit, it takes about 25 days from egg to adult. But you can see as the temperature increases, the days from egg to adult get much shorter. And if you have constant 30 degrees Celsius, 86 Fahrenheit, it can go from egg to adult in a week or less, slightly different for males. So I mean, that's all to point out how quickly the populations of spider mites can grow, as you all know. Seven days, if conditions are constantly 30. And so this just points out the rate of growth. You can see as we get up to 30°C, we get a really high rate of growth. But what's just a little bit cut off here is that at 35 degrees Celsius, these can't survive. It's too hot.
How much is that in Fahrenheit for the layman?
Well, 30 degrees Celsius, in the brackets there is Fahrenheit, so that's 86. So 35, we're into almost the mid-90s, I think. So female longevity, how long do the adult females live? And same thing at constant Celsius. So as the temperature increases, the mites don't live as long. You can see the numbers. It goes down to about 17 days versus 22 at the other end, where it's 15 Celsius or 59 Fahrenheit. But how many eggs do they lay? So these are some numbers about numbers of eggs per female per day at constant temperatures. So up to about 7 eggs per day per female if it's constantly 86 Fahrenheit. So it gives you just a little bit of idea of the biology of these pests. But one thing is that we never have constant temperatures out in the field. So what happens under fluctuating or variable temperatures? So there's a more recent paper where they did a little bit of work on this in the lab. And what they designed is temperature regimes that started at 22 degrees Celsius. So we're in the mid-70s there, I think. And they had a constant, so they didn't fluctuate the temperature at all, 22. Then they had another treatment where it was 22 plus or minus 3 degrees Celsius. So the amplitude of that change is 6. And they went on up all the way, so it's 22 plus or minus 12. And they change that temperature every 24 hours. So this is a little bit more simulating what goes on in the field with temperatures that are going up and down. So now how does that affect the mites? I know these graphs are a little bit hard to see, but I'll hopefully point it out clearly. So this is, on the x-axis, they're graphing out this amplitude from 0 to 24. And here is the oviposition period. So how many days are the females laying eggs? Well, when it's constantly 22, it's about 25 days. As that temperature fluctuation gets really high, they lay a lot less eggs, down to about 10. And this is the total number of eggs. So the number of eggs also decreases as that temperature fluctuates a lot. These ones also show how long the mites are living. Both the males, this is the females and this is the males. So as the temperature fluctuation gets higher, their longevity goes down from about 30 days to less than 20 days. For males, it's almost about 10 days. And so finally, how long does it then actually take for them to go from egg to adult? And so that number also decreases a little bit at these really high fluctuations. Well, I was going to go through some more technical information about resistance, but I'm going to skip a little bit of that. But basically say that Two-spotted spider mite is probably the most resistant insect mite pest in agriculture. You know, it's been documented resistant over to 92 active ingredients, 367 documented cases. I just read an article that came out of strawberry in California, Southern California, and they found resistance there to hexythiazox and to bifenazate. So it's nothing new.
We need to make sure and rotate our chemistries, guys. If you're not rotating your chemistries, this is what's going to happen.
So why are spider mites so resistant, or why can they be? Well, we already talked about high fecundity, very short life cycles. Also, males are produced from unfertilized eggs, so some of these things are important. If we want to talk scientifically, there's really two main ways that insects or mites can be resistant to products, and that is if where the miticide, the molecule, has to bind to affect the insect in the cell. Either there's a mutation and it doesn't bind, so the miticide doesn't work, or there are enzymes that break down the miticide before it affects the target site. So there's been some questions. So Jay said that the mode of action of bifenazate was unknown for a long time, and now some work out of Europe is showing that the mode of action might be very similar to cainamite or acequinacil, and there has been some lab colonies of two-spotted spider mite where cross-resistance has been a factor. So that's one thing that we need to work on in the future and keep thinking about. I'll basically skip the rest and go to basically what I've looked at this year. Actually, I first was made aware of the mites problems in the field in February. So we started spraying some of these mites with bifenazate with acromite in the lab, and we used something called a Potter spray tower, where a petri dish with a leaf disc with mites on it is put here. There's a little nozzle here, and the miticide is sprayed through here onto the mites, and then we hold the mites on the petri dish, in the petri dish on the leaf disc for a number of days afterwards. And so here's what we've graphed out is the percent mortality of those adult mites. So if you look at these bars first, so this is a susceptible colony of mites that have been in the laboratory at the Gulf Coast Center for generations, for years, and they were highly susceptible at 24 hours to acromite. So 100% of them died. In the control, we got a little bit of death. So in the next set of bars here were mites that were collected in the field on February 23rd. They were held in a growth room until March 7th, until we got ready to test them. And the problem with this is we got good mortality with acromite, but we also got a lot of mortality in the control. And this is likely due to the fact that the mites were living on strawberries, and then we tried to put them on beans, and that switch in host was not favorable to them, so a lot of them died when we did that. So we went back to the field, same field on March 10th. We collected mites again, and this time we sprayed them under here, actually on discs of strawberry leaves, so we weren't switching the hosts. At 48 hours, we didn't see much effective acromite. The mortality was quite low. But we kept those mites for another 2 days at 96 hours, 4 days later, and at that point, the mortality from the water controls was about the same, but the mortality with the acromite was quite a bit higher, around 80%, so not quite 100, but still pretty good. In this field, acromite was applied on December 1st and February 12th, cainamite once on December 25th. So it was never applied during this period when we were collecting the mites, just to point that out.